In this video, we'll work on 35 ideas in SMC, Senior Mathematical Challenge from UKMT 2023, and I leave 22 homeworks from Stanford Summer Camp AMC, the most prestigious national exam from USA. And as I said before in my previous videos, there are around 40-50 important formulas in each topic: combinatorics, algebra, number theory, and geometry. If you want to learn them or want to prepare for any math exam, feel free to send message my WhatsApp number in the description. Okay, idea 1, 2, 3, Heron's formula, mod 3 casework considering small examples. This formula, most restricted cases when we have caseworks, when we have uh, truth teller and liars, we should do what? In coordinate geometry, distance of 2 points, distance of a point from a line. Vieta's formula in polynomial, Legendre's formula, multiples of A from 1 to n, Venn diagram, ideas in trapezoid, unit circle, divisibility, the properties. When we have four important and basic things in trigonometry, when sine alpha equals sine beta, in general, we can conclude what? Cos alpha, cos beta, cotangent and cotangent. And next idea is we work on, let me see. Okay, idea 29, divisibilities and properties. For example, 30, a divides a divides b, a divides b, c. If a divides b, a divides c, a divides b minus c, a plus b plus c squared. And we have tangent to a circle, the radius is perpendicular. 35, something in trigonometry, and something about arc sine x or sine inverse. Okay, 36 ideas, and also, as I said, 22 homeworks. Okay, let's start again. As I said before, if you want to work on any problem, if you want to learn background ideas, feel free, these are the solutions, all these things. If you want to learn background ideas that are repeated in each year in BMO1, SMC, BMO2, any math exam, IMO, feel free to send message to my WhatsApp number. Okay, let's start with problem 1. What is the value of square root of 2023 over this? Try first on your own. It's easy. Okay, so let's calculate. It will be square. At first, let's prime factorize. It is what? It is square root of 2023 over 7. Let me tell you one important thing. Try to know prime factorization of important numbers like the year 2023, years 2024, something like this. For example, 2023 prime factorization is what? It's multiple of 7 times 17 squared. 2024. So if you check 2024, it is multiple of what? Multiple of 8. Why? You should consider, it is ideal 1. If you want to know a number is multiple of 8 or not, consider for 8 last 3 digits. Okay. You will see it's multiple of 8 because last 3 digits is 24, it's multiple of 8. If we divide by 8, it will be 2 times 8, 16, 42, 5 times 8, 2, 24, 3. And then if we check divisibility of 253 by 3, it's not multiple of 3 because sum of digits equal to 10. By 5, it's not multiple of 5. By 7, it's not multiple of 7 because 3 times 7, 21, 43. It's multiple of 11. One idea for 11, when you want to check from right, try to consider plus minus plus minus. So if you consider plus minus plus, 3 plus 2, 5 minus 5, 0. So it's 8 times 11 times what? 2. For next year, for example, 2024 can be used. 2 times 11, 22, 23. So it's what? 2 cubed times 11 times 23. Now, if you divide this, it will be what? 2023 divided by 7 is 17 squared. Square root of 17 squared is 17. So the answer is choice C. For many numbers, we have rules for 9 and how we can find these rules. If you want to learn them, like the 40, 50 important ideas in each topic, feel free to send message, my WhatsApp number in the description and comments. Okay. Now, try problem 2. It says, what's the difference between 1/3 and 0.333? So it is only a subtraction. Let's calculate this. So try first on your own. Okay, let's try this part together. Let me tell you, 1/3 is what? 0.3333 if we calculate and solve. This number is what? 0.333. So if we subtract, it will be what? 0.123000 and then 33 this. Okay, so if suppose this number is x, if we say 1000x, then it will be 0.333 and so on. It is what? It is 1/3. If we divide both sides by 1000, x will be what? 1 over 3000. One solution is this. If you don't know this part, solution 2, we can subtract like this. 1/3 minus 0.333. This one is a bit easier. 1/3 minus 333. How many digits do we have after decimal point? 1, 2, 3. So 10 cubed or 1000. Now if you use common denominator, 3000, 1000 minus 3 times this, minus 999. Which will be what? 1 over 3000. So the answer will be choice C. Okay. Now let's try problem 3. Okay, now try problem 3 first on your own. Okay, let me tell you an idea here. I told you idea 3. Okay, idea 4. When something increased by, for example, r%, so it means that you should multiply that by 1 plus r%. When something is decreased by r%, you should multiply it by 1 minus r%. Okay? Now, if you consider area of a triangle is what? Is altitude or base times height over 2. Now in next part, B increased by 20%, so we multiply it by 1 plus 20%, times H times decreased by 15% minus 15% over 2. So it will be BH over 2 previous area times 1 plus 20%, 1 minus 15%. So we should find this effect. Okay, this effect is what? 1 plus 20% is 1.2. 1 minus 15% is 85% or 0.85. So it's 12 over 10 times 85 over 100. 10 is 5. 17 to 6. 6 times this is 102, 100. It is what? It is 102 or 1 plus 2%. So this one will be what? Will be 1 plus 2%. It is multiplied by 1 plus 2%. Means what? It increases by 2%. So the correct choice is D. Okay, if you had another question about these types of problems or wanted to solve more related problems, as I said, send message to my WhatsApp number. Okay, now let's try problem 4. Okay, try problem 4. Go down, try this problem first on your own. Okay, let's try this problem together. In 2016, the world record for completing a 5,000 meter three-legged race was 19 minutes and 6 seconds. It was set by Damien Thacker and Luke Simmons in Sheffield. What was their approximate average speed in kilometer per hour? Okay, so 5,000 meter, 19 minutes and 6 seconds. Okay, 19 minutes and 6 seconds. So we want to change it to kilometer per hour. In 2 steps, we will do that. So at first, we want to see 5,000 meter is what kilometer? So it's 5 kilometer. Now the distance will be okay. What about the time? So we want to see it will be how many hour? So 19, for example, look, when you have 30 minutes, you divide it by 60 minutes and it will be what? 0.1 half hour. Now here we change it to because here we have seconds, so it will be what? 19 minutes. 6 seconds will be what? Look, for example, when we have 30 seconds, if you want to see it's how many minutes, you divide it by 60, and it will be what? It will be 1 half or 0.5 minutes. Now it's what? 6 over 60 minutes. Now we divide it again by 60, and it will be what? Hour. Now we should calculate this part. We should simplify. It's 19 plus 6 over 60 is 1 over 10 over 60. Now we multiply both numerator and denominator by 10. 190 plus 1 equals 600. So it will be 191 over 600. Okay, now here it is 5 kilometer in what hour? This hour. Now we want to see per hour is what? Okay, now we want to see in 1 hour what happens, okay? In 1 hour, it will be what kilometer? Okay, so try to find the question mark first on your own. What kilometer in 1 hour? Now let me tell you something. For example, if it is in 2 hours something, then we should divide by 2. 1 over 2. So when you want to find question mark, you can also say you can cross multiply. For example, if it is x 1 times 5, 5 equals x times 191 over 600. We can use approximation here. For example, we can say, okay, 2, because it says approximate this over this, so it will be x over 3. Also, you can approximate L here. X equals what? Equals 15. Okay, so it's 15 kilometer per hour. So let's see, the correct choice is what? The correct choice is C. Okay. So here, finding these units step by step can be useful in this problem. Let's try next one. It was 4. Now problem 5. Okay, try problem 5 first on your own. Okay, let's write here. It is 2, obviously. It is 2, it is 3, it is 3, it is 3, 3. So the length of our triangle is what? Is 6. So we can write something like this. And 5. So it will be something like this and this. Okay, so this one is 5, this one is 5, this one is 6. Because it is isosceles, when you want to find the area, we draw altitude. And these two triangles, it is also median because it is isosceles. Let me write ABC. So it will be 3, 3. So if you use Pythagorean theorem, square root of 25 minus 9 is square root of 16, which is 4. Famous triangle 3, 4, 5. It is 40. And then the area is altitude times base 6 over 2, 24 over 2, 12. One solution is this. But maybe, for example, here, if we didn't have two equal sides, let me tell you a general formula. Let me see, it will be what idea? Which idea? Heron's formula. I told you up to idea 4, idea 5. Heron's formula. If you want to learn also, and also it has a different form. You have a homework in AMC problem that you should use Heron's formula, but in that problem, we have another form of Heron's formula. If you want to learn that and solve the related AMC problem, feel free, as I said before, to send message to my WhatsApp number in the description. Okay. Heron's formula here is what? S, we call S semi-perimeter, 5 plus 5 plus 6 perimeter over 2, which is 16 over 2, 8. Now the area will be S, the formula is this area equals S times S minus A times S minus B, S minus C. A, B, C are the three sides of the triangle. So it will be square root of 8 times 8 minus A is what? 8 minus 6, 2. 8 minus B is what? 8 minus 5, 3. 8 minus C is also 3. Square root of that, it's 8 times 2, 16. 3 times 3, 9. Square root of 16 is 4. Square root of 9 is 3. It's 12. Okay. It was Heron's formula. As I said, if you want to learn other formulas for some in geometry, 40, 50 important formulas, you can send message to my WhatsApp number. Okay, it was problem 5. Let's try problem 6. Okay, try problem 6 first on your own. Okay, let's try this problem together. It says how many lines of three adjacent cells can be chosen from this grid horizontally, vertically, or diagonally such that the sum of the numbers in the three cells is a multiple of 3. Because we are working in multiples, for example, we want to find multiples of 3. One good thing is to consider mod 3, then it is easier to calculate. It will be which idea? Idea 5, idea 6. Here, when we are working with this, we consider mod 3. Okay, so here it will be 1, 2, 0. So let's draw a 4 by 4. For example, like this. And let's draw this one, this one, this one, this one, 4 by 4, this one, and this one. Okay, so if we draw 1, 2, 0, and 1 again, 5, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, and 1. Okay, so now we consider caseworks. The three cells that are adjacent, they are in row or so. The next idea, casework. There are lots of problems with casework. Let me see how many homeworks. How I told you homework 1, homework 2. One problem of last problem of SUMAC. SUMAC is for Stanford Summer Camp. Problem question number 8, 2022. Homework 3 is promise problem. It's another summer camp. A problem related to ANG and divisors. If you want to know exact problems or what, feel free to send message to my WhatsApp number in the description and comments. Homework 4. One problem from HMMT Harvard MIT Math Tournament. I know 2023 combinatorics round. It was problem 2 or 3. And that it was we have a 3 by 5 table. We want to tile it. Homework 5. One problem from AMC 12A 2022, also 10A. We have homework 6 for USA. AMC is for USA. AMC 12B 2022. This problem related to a string, for example, each element is 0, 1, 2, 3, or 4. This problem related to cells, each of them black or white. I should search that exact problems are what. As I said, if you want to know exact problems are what or want to learn more ideas, how to apply them, how to prepare for BMO and other math exams, feel free to send message to my WhatsApp number in the description. Okay. Now let's see casework means what in this problem. The problem says the elements are horizontally in a row, in a column, or diagonally. So, first case, consider that they are in a row. Okay? And try to see how many three adjacent cells can be chosen horizontally that their sum is multiple of 3. Try to calculate this case first on your own. Okay, let's try this part together. Okay, it will be what? Let's calculate. 120 is good. 3. 201 good. This one 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 good. So 1, 2, 3. Each row 2 cases. We have 4 rows. 4 times 2, 8. Now consider vertically. Try this part first on your own. Okay, now again consider the columns. This column 1 case, 2, so it will be 2 plus. What about this column? Again, we will see it is 2. This column again 2. This column again it will be 2. 2 plus 2 plus 2 plus 2, 8. Now third case. Consider diagonally. First consider diagonally like this. Next one second type. This one. First try this one. Okay, try first on your own. Okay, for these parts, let's see, question mark is what? We can say this one, 1, 0, 2, 3, this one, two cases, this one, this case, three, this one. So one here, if I want to show one here, one here, one here, one here, four. Okay, now try to calculate this type diagonally. Okay, so let's calculate this question mark. Again, this is good. It is good. This one is good. 0, 0, 0, 1, 1, 1, 3, 2, 2, 2. 1, 2, 3, 4. So it will be 4. So the answer is 8 plus 8, 16 plus 4, 20. Plus 4, 24. Okay, so the answer is, which one is choice B? Okay, now it was problem 6. Let's try problem 7. Okay, try problem 7 first on your own. Okay, for these types of problem, we have one useful idea. It was idea 6, idea 7, idea 8, considering small examples. Okay, considering small examples. Many problems of BMO, some also BMO2. I released full solution of last BMO2, BMO1. I solved many problems of those exams with BMO1, BMO2, with considering small examples. Okay, let's write. So here it says 25th term, we consider third, fourth term, fifth term, like this. 2023, 2022, then 1. 2022 minus 1 is 2021. Then 2020 the difference. Then it's 1 again. Then 2019, 2018. Then 1 again. And as you can see, it is, for example, A1, first term, second term, A2, A3, A4, A5, A6, A7, A8, A9. Okay, we want to find the pattern is what? So as you can see, it's 2023. Because we have the repetition here, 3, 6, similar to this one. 25 mod 3 is what? The remainder when divided by 3 is 1. So it is similar to these terms. Okay, so it is what? It is negative 2. This one to this one is again negative 2. So we can say what on this formula for it is arithmetic sequence. And the idea is what? AN equals A1 plus N minus 1D. This formula is so much useful for these types of problem. So A1, so here, for this one, because here is A1, A4, we consider that, for example, this one is B1, this one is B2, this one is B3, so A25 is what? Look, 7 minus 1 over 2. Let's see, 4 minus 1. The difference is 3, A1, A4, A7. So 1, it is second, 3k plus 1. So 3 times this minus 2. Okay? Or you can say 4 plus 2 over 3. Look, 4 plus 2 over 3 is what? Is also, again, you can use this part for finding the index. It's be what? Look, 7, because the difference is 3, you can say, okay, 7 plus 2 over 3 is that. Or we can say, if you want to consider the index, this index is what? C1 is 1, C2 is what? Is 4, C3 is 7, and we want to see what is 21. So Cn is C1 plus n minus 1 times d. Okay. It is what? C1 is 1 plus n minus 1 here times common difference is 3. So we want to see what is 25. Okay, so if we write it 25, 3 times n minus 1 is 24. So n minus 1 is 8, so n is 9. One way is this, is B9. Or we can say 25 plus 2, 27 over 3, 3. Okay, when you see it is 1 4, the difference is 3, you should work on denominator 3, something like this. Okay. Now we want to find B9. We know B1 is 2023. So Bn is B1 by this formula again, plus n minus 1 times d. So we can conclude B9 is B1 2023, 9 minus 1, 8. Common difference is what? Negative 2. So it's 2023 minus 16, which is what? 2007. Okay? And the correct choice is this. Okay, so this formula is so much useful arithmetic sequence formula. If you want to learn other ideas like this, 40, 15 point formulas, you can send message to my WhatsApp number. Okay. Now let's work on next one. We solved problem 7, problem 8. Try problem 8 first on your own. Okay, let's try together. 99, 0.4, 94949, and so on. 0.4444, and so on. So it will be 99, 0, 5, 0, 4 minus 4, 0, 9 minus 4, 5, 4 minus 4, 0, 9 minus 4, 5, 4 minus 4, 0, 5, and so on. So we want to calculate this number. We define it as x. We want to find it inside itself. Means what? If you multiply x by 100, look, the repetition is 2. Because the repetition is 2, when you multiply by this, it will be 0, 5.0505, and so on. So now, if we subtract 100x minus x, this part will be cancelled. Okay, so this idea, let me define idea 9, idea 10. Find inside itself. Let's define it as this. So this will be what? 0, 5 is 5, and after decimal point will be cancelled. So 99x is 5. So x is 5 over 99. Now 99 times x will be what? X is 99 will be cancelled. 5 will be left. Look, 99x is what is 99 times 5 over 99. 99 will be cancelled, it's 5. Let me tell you some homeworks to get good at finding inside itself. Here I told you 9 homework, 9 ideas. How many homeworks? Homework 5. Homework 6. In for example, SMC, SMT, Stanford Math Tournament, we have these types of problem in many of these types. Okay, so homework 6, for example, try to find this. Square root of 2, square root of 2, square root of 2, and so on. Homework 7, for example, 1 plus 1 over 1 plus 1 over 1 plus 1 over. Homework 8. Let me add a page. Okay, homework 7, homework 8. We can solve it with two ways. One way is to find again inside itself, 1 over 4, 1 over 8, and so on. Homework 9 is a bit harder, square root of 2 times square root of 3 times square root of 2. Okay, now let's try next problem. Problem number, if you want to learn other ideas like this or want to solve more homeworks from prestigious math exams, feel free to send message to my WhatsApp number in the description and comments. Okay, problem 9. Okay, now try problem 9 first on your own. Okay, so for these types of problems, I10, idea 11, we should consider the most restricted case, like case for problem. Most restricted case means what? Here. For example, so look one across. Here it is a square number, so it can be what? It can be, for example, and look, this cell is not 1, only it shows that, for example, 1a square across means that this 3 from here to here, this 3 digit number should be a perfect square. For example, it can be 125, 121, 11 squared, 100, or lots of cases, so it is not a good thing. Fourth power 3 across. So let's consider this. 2 to the 4 is what? Is 16. It's not good. 3 to the 4, 81. 4 to the 4 is 2 to the 8 is 256. It is good because it's a 3-digit number because of the problem. 5 to the 4 is 625 is good. 6 to the 4 again will be greater than 1000. Okay, it's not good. So we can erase this. Twice a fifth power. So 2 times 2 to the 5 is 32 times 2, 64. It's not a 3-digit number. 2 times 3 to the 5 is 2 times 243, which is 486. 2 times 4 to the 5. 4 to the 5 is 1024. Again, it's not good. Okay, so this one also will be bad. Let me erase this. And a cube number is what? We can have, for example, 4 cube 64, 5 cube 625, 125, sorry. We have lots of cases. 6 cubed, 7 cubed, up to 9 cube because 10 cube. So you have lots of cases here. So this one is not good to start with. The best one is this one because we have only one case, but this one here we have two cases. Okay, both of them are good, but this one is better. So 486, one down. We consider 486. Now after that, most restricted case is what? Is this one. 3 across. This one, 256, it starts with 6, so we should select 625. Now, the square one, this one should be square, this one should be cube. Cube again is more strictly. So, it is cube. 2 down. So, 4 cubed is 64, 5 cubed is 125. It can be only 5 cubed because we can select 5 cubed to 9 cubed because last digit is 5, it should be multiple of 5. Because 10 cubed is 1000, it's not a 3-digit number, it's a 4-digit number. So between 5 cubed to 9 cubed, the only number that is multiple of 5 is 5 cubed. So this one will be 125. Now a square number. This one. It is what? 20 squared is 400. 21 squared is 441. 22 squared is 484. 23 squared is 529. One important thing, try to memorize up to 31 squared, less than 1000, okay? It increases your speed when you want to solve these types of problems. Okay, so 441, the only, because it ends in 1, so the only case is 441. So our star is what? Is 4, okay? Before this exam, I released some ideas and I solved exactly problems with same idea of past years of SMC. If you saw that, you could solve this problem easily. If you want to solve these types of problems or prepare for any math exams, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, it was problem 9. Okay, now let's work on next page. Problem 10. Try problem 10. Let's copy. Okay, try this problem first on your own. Okay, so let's try this problem together. One way is to factor from 2 to the 2022. It will be 2 squared plus 2 plus 1. 4 plus 2, 6 plus 1, 7. So 7 is a factor. Now, if we want to check other numbers, one way is to use modulo. Let me check how many ideas I told you. Idea 10, idea 11. For these types of problems, one way is to use mod. So for 6, we should check 2 and 3. We know it's multiple of 2 because all numbers are multiple of 2. For 3, if you don't know mod, feel free to send message to my WhatsApp number in the description and comment. Look, the difference should be multiple of 3. So 2 is negative 1 mod 3. So negative 1 to the even number plus negative 1 to the odd plus negative 1 to the even. Mod 3 will be what? 1 minus 1 plus 1 will be 1. So the remainder when divided by 3 is what? Is 1. So it's not multiple of 6, also not multiple of 9. Now let's check 8. 8. Each term is multiple of 8. It's correct. For 10, we know it's multiple of 2. We should check 5. We know 2 squared is 4. Mod 5 is negative 1. Okay. So the first one is what? It's 2 squared times 1, 0, 1, 2. Plus 2 times, so 2 times 2 to the 20, 22. Or we can do something. We can factor from 2 to the 20, 22 times 2 plus 1, 3. If we cancel mod 5, it's 4, it's negative 1 to the 1, 0, 1, 2. This one is 2 squared. 2 squared is 1 to the power of 10, 11 times 3. So it will be what? It will be 1 minus 3, which will be negative 2. It's not 0 mod 5. So we will see it's not multiple of 10. Okay, so 2 numbers. The answer is choice B, 2. If you want to learn how to work with mod like this, or 40, 50 important formulas in each topic, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, let's try problem 11. Try problem 11 first on your own. Okay, let's try this problem. It says when Lysander, Yasser, Zui make the following statements. Okay, let's define, label it W, Y, X, Z. Okay, X is lying. So for these types of problem, again, we should use case work. Okay, for the problems like these, you start from one of them, idea 11, idea 12. Start from one of them and consider casework. He's telling the truth or he's a liar. Okay, let's start from first one, W. Suppose W is, for example, truth teller or liar. So first, let's check this one. It says Xander is lying. Okay, so Xander will be liar. Xander. Yasser is lying. So because he is liar, then we conclude Yasser should be truth teller. Now Yasser says Zui is telling the truth. Because Yasser is telling the truth, so Zui is telling the truth. Okay. Now we should see, do we reach contradiction or not? Zui Wenlu is telling the truth. Okay. Truth teller, it will be okay. So in this case, how many truth teller do we have? 3. L. Suppose W Wenlu is liar. So Wenlu says Xander is lying. So he will be truth teller. Xander says Yasser is lying. So liar. Zu is telling the truth. So Zu will be liar. Zu Wenlu is telling the truth. Okay, we don't have any contradiction because he's liar. He's liar. He's lying. Saying that Wenlu is telling the truth. This one will be okay like this. So how many truth teller do we have here? 1. So the answer is 3 or 1. It is like this. Okay. Now let's work on problem 12. Okay. Okay, so try problem 12 first on your own. For solving this problem, we can solve it in 2 ways. One way with formula, one way without formula. Let's solve first without using any formula. You say, okay, 50 factorial, which numbers are important? 7, 14, up to 49. Okay, so here you say 7, 14, 21, 28, 35, 42, 49. So 1, 2, 3, 4, 5, 6, 7. This one has 2 7, 7 squared. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the most basic way. 8. Solution 3 solution. Solution 2. Let me tell you an idea. Idea 13. If you want to know that from 1 to n, how many numbers are multiples of a? It will be n over a. Floor of that means round down. So here you say, okay, 49 over 7, and all of them, we have these number of multiples of 7 and plus 1 because 49 has two sevens. So it will be 7 plus 1, 8. Solution 3, that is more professional, is to use Legendre's formula. Idea 14, Legendre's formula. So if we want to find power of p in n factorial, power of p in n factorial, let me write it here. Power of p in n factorial. For example, here we want to find power of 7 in 50 factorial. So here we write it as this Vp of n factorial. Okay, it means power of p in n factorial. The formula is what is n over p plus n over p squared plus n over p cubed and so on. Why? Because n over p calculates number of, for example, here. If you want to use this formula, it will be v7 of 50 factorial. Let's see. It will be 50 over 7. It calculates multiples of 7 plus 50 over 49. Calculates multiples of 49. 50 over 7 cubed. And so on. This one's 0 from here. So it will be 7 plus 1, 8. Why is this correct? Because here we calculate multiples of p, here multiples of p squared. So if a number like 49 is multiple of p squared, we calculate it twice. And we have to calculate it twice. If a number is multiple of p3, we calculate it 3 times. Okay, like this. And this formula, famous formula, by this we can solve. For any factorial and any prime, we can solve with Legendre's formula. Okay, idea 14. And I know some problems of AMC can be solved with this. Let me see how many homeworks did we have. And homework 9. Okay, homework 9, homework 10. We have AMC problem that can be solved with this idea. If you want to learn, no, I should search. If you want to know exact problem is what, as I said before, feel free to send message to my WhatsApp number in the description. Okay, problem 12, we've solved that. Problem 13. Okay, try problem 13 first on your own. Okay, it says PQRST is a regular pentagon. So let's draw that first. For example, it's like this one. Like 131. If you want to find the angle, let me tell you, it's a new idea. Idea 14, idea 15. For pentagon or any regular, the sum of the angles is always 180 times n minus 2, okay? Sum of the angles. And here, for 5, it is 180 times 5 minus 2. Because it is regular, means all angles are equal, we divide by 5. This one will be 36, 5 minus 2, 3, 108. Okay, so each angle is 108. So if we draw, it will be 108, and the length is 80. Okay, something like this, length is 80. Okay, 180, 72, something like this. And okay, so it will be like this. Now we define this one as PQRST. So here it says what? It says U lies on ST such that QPU is 90. Okay, so QPU is 90. It will be something like this. This one is 90. Now it says in triangle, what's the ratio of the interior angle in the triangle PUT? Okay, this angle we know is 108. This angle is 108 minus 90, which is 18. And this angle is 180 minus sum of two angles here. 180 minus 108 minus 18. So 180 minus these two angles, 126. Okay, so it will be what? It will be 54. 54 is 3 times 18. So it will be 3 times 18. This one is 6 times 18. This one is 18. So ratio 3, 6, 1. Or any permutation of that. 1, 3, 6. Okay, so it will be choice A. Now, in pentagon or for example hexagon, regular hexagon and octagon, these things are important. Finding the length, angle, chasing. If you want to learn how to work with regular hexagon or octagon, as I said before, feel free to send message to my WhatsApp number in the description and comments. So pay attention to regular, all properties of regular hexagon and regular octagon. Okay. You can find all lengths as homework. I can say these two things. Homework 10, homework 11. Find all lengths, all angles, lengths of all diagonals, areas. So, homework, I said 10, 11. Homework 12. And if you had any question, you can send message to my WhatsApp number. Okay, it was problem 13. Now let's try problem 14. Okay, now try problem 14 first on your own. Okay, this problem says the points P, D negative D, and Q 12 minus D, 2D minus 6 both lie on the circumference of the same circle whose center is the origin. What is the sum of the two possible values of D? Okay, we have a circle. The center is 0, 0. We call it O, and for example, PQ. Okay, but P is D negative D. Oh, yes, it will be good. Okay, now let me tell you something. For this problem, we need to know the distance of 2 points in coordinate geometry. So we had idea 15, idea 16. If you have 2 points, we want to find the distance between them. If it is x1, y1, and this one x2, y2, and suppose this length is d. By Pythagorean theorem, we can prove that d equals square root of y2 minus y1 squared. So if we draw this one, y2 minus y1 is this part, and x2 minus x1 is this part squared. Okay, we have also other here, this one only useful, but we have lots of other formulas. For example, like when we have a point, and we have a line and a point, and we want to find the distance. Here, for example, it is O. It is, for example, let's consider it's P, x0, y0, and this line is ax plus by plus c equals 0. And we want to find the distance here. In this part, d is absolute value of ax0 plus by0 plus c over square root of a squared plus b squared. Okay? So we have these formulas now here. OP equals OQ, the distance. So OP squared equals OQ squared. If we use idea 16, OP, because it is 0, it's d squared minus d squared plus minus d squared equals OQ squared. OQ is what? 12 minus d, 2d minus 6. 12 minus d squared plus 2d minus 6 squared. Okay. Now you should solve this equation. Try first on your own. Okay, here we have d squared plus d squared, 2d squared. Here, 1, 4, 4, 12 squared minus 24d plus d squared plus 4d squared minus 2 times 2 times d is 424d plus 36. Okay. Now, here, if we want to simplify, let's take all things to right side. 5d squared minus 2d squared, 3d squared minus 24 minus 24 minus 48d plus 144, 136, 150, 180. Okay, if we divide both sides by 3, 0 equals, okay, 0 equals d squared minus 16d plus 60 here because we want to find some of the roots. You can solve it. Okay, so here if we factorize, we can say 0 equals plus minus minus 10 d minus 10 d minus 6. Okay, so d is 10 and 6. So the sum is what? 16. Okay, also with Vieta's formula, we could solve this. It will be choice E. Let me tell you idea 18. Vieta's formula, but we have for degree n. For degree 2 that we need ax squared bx plus c equals 0 if you have roots r1, r2, r1 plus r2 is negative b over a. Because here the problem says we have two values and some of them is what? So b is what? Negative 16, a is 1. Negative 16 over 116. Okay, without calculating roots, also we could calculate the sum by this formula. Okay, so the answer is choice E. It was problem 14. Now let's try problem 15. Okay, try problem 15 first on your own. Okay, for this problem, okay, problem 15. In Bethany's class of 30 students, twice as many people played basketball as played football. Okay, so we consider basketball equals 2 times football. Twice as many people played football as played neither. Okay, so here we can say F is 2 times N, football, neither. And so which of the following options could have been the number of people who played both? So when we have something like this, we should draw a Venn diagram. Let me see, it will be idea 19. Idea 19. We call it Venn diagram. So we draw like this. It will be like this one, like this one. So it will be F, it will be B, it will be N. Suppose the common term is C. Okay? So F is this part plus this part. Okay. Now let's consider, for example, this one X, this one Y. We know what? We know X plus C. Here, B is 2F. So C plus Y, B equals 2F. 2 times X plus C. Okay. Now the other one F. And we know all of them equals 30. So F equals what? F equals 2 times N. Now, N is what? N is 30 minus X minus C minus Y. So it will be what? And it says what? Could have been the number of people who played both. So we want what? C. 2N is what? Is 2 times 30 minus X minus C minus Y. Okay, and here it is C plus Y, basketball and football. Okay. Now work on these two equations. C can be what? Try first on your own. So let's work on this part. Here we know f is what? C plus x. Here is what? It is 60 minus 2 times x plus c minus 2y. So if you take it to left hand side, 2 times x plus c plus x is 3 times x plus c equals 60 minus 2y. From here, we know 2 times x plus c equals c plus y. Okay, now if we, let's multiply this one by 2, this one by 3 to cancel x plus c. It's 6x plus c equals 120 minus 4y. And this one is 6 times x plus c equals 3c plus 3y. Okay, so left hand sides are equal, so we can conclude right hand sides also are equal. So we can say what? We can say 120 right hand sides minus 4y equals 3c plus 3y. Okay, we take these to left hand side, so 120 minus 7y equals 3c. So when we see some problems like this equal 3c, when we see some problem like this and we want to see possible values of c, we should use modulo, I19, I20. Mod, we should use, when we see, for example, 120 minus 7y, 3c, and we want to find possible values of c, we should use mod 7. Okay. If we use mod 7, it will be 120 is congruent to 3c mod 7. Now we can divide both sides on, and one idea in modulo is this. If we have AC is congruent to BC mod M, and you want to divide both sides by C, A is congruent to B mod what? They are equivalent. Mod M over GCD of M and C. It was useful also in, let me see, how many homeworks do we have? Homework 11. Homework 12. Last problem of AMC 10B 2022. Last AMC for America. Is this also in 12B? We have similar problem, but here it is problem 25. Okay. That you should use this idea division. So if you divide by 3, 40 is congruent to C mod G7 over GCD of 7 and 3. GCD of 7 and 3 is 1. So it will be mod 7. And so 40 is mod what? Is what mod 7 is 5. So C, one necessary condition, not sufficient. But let's see the choices. Which choice? The remainder of each choice when divided by 7 is 5. Only choice D. Okay, it was problem 15. Now let's try next one. Problem 16. Okay, so try this problem 16 first on your own. Okay, let's consider edge length of cube that is 2 root 2 is a. So, or let's write it as 2x, okay, or 2a. So this length is a, this length is 2a. Let me call this one, for example, AB. Try to find all side length of trapezium GHBA. Okay, try to find GH is what, GA is what, HB is what, AB is what, and by using this, at first find these four lengths in terms of A, then you can find the area of this trapezium, and then you can find the length and then area. Try first on your own. Okay, so let's calculate. At first, let's calculate GA. By Pythagorean theorem, we can say GA squared equals 2a squared plus a squared. So it will be 4a squared plus a squared, 5a squared. So GA is a root 5. Okay, we know a is root 2, but we work with a. Also, we can work with root 2. So GA is a root 5. So we can write it like this. Now, similarly, HB also is same. Now, this one is a, this one is a. For finding GH, again, we can use Pythagorean theorem. GH squared is a squared plus a squared, 2a squared. So GH is a root 2. Okay. And also in general, because it's 45, 45, and we have AA, hypotenuse is a root 2. AB is left here is 2a, 2a. So again, if we write Pythagorean theorem, AB is 2a root 2. Okay. Now, next idea. When we have a trapezoid, one good thing, important thing, is to draw altitude. So idea 22. In trapezoid or trapezium, draw altitudes. And as homework, 13. One problem of AMC for America, 20A. America, BMO, and AMC are the most two prestigious national exams. AMC 12A 2022. Okay, now let's draw this trapezoid here. It will be something like this. Okay, so let me just check this one. 1, 2, 1, 2. Okay. So we can say it is what? GHBA. HBA and GA is a root 5. GH is a root 2. And this one is 2a root 2. So first, if you apply this idea, we draw this one. This one. So it will be what? It is a root 2. Okay. Now, because AB is 2a root 2, so when we subtract a root 2 over 2 is left for this part, and a root 2 over 2 for this part. So we need altitude. H squared y, because idea 23, the area of a trapezoid is h times sum of the bases over 2. Because you can divide to 2 triangles. Okay, homework. How many homework? 12, 30. Now, h squared is what by Pythagorean theorem is a root 5 squared minus a root 2 over 2 squared. Okay? So it will be what? It will be 5a squared minus 2a squared over 4. So it will be a squared over 2. So if you use common denominator 2, 10 minus 1, 9a squared. Okay, so h is a root 3 over 2. So if you want to calculate area, h is a root 3 over 2 times sum of bases a root 2 plus 2a root 2 over 2 by idea 23. If we simplify, it will be what? Simplify this. So here, we can say what? A root 3 times 3a root 2 over 2 times 2, 4 equals 3a squared root 6 over 4. And a is what? A is root 2, we said. So if we replace root 2, it will be 3 times 2, root 6 over 4. So it will be 3 root 6 over 2. Okay, so it says area. So let's see, do we have any careless mistake or not? Let's check it. Okay, sorry. Here, when we take square root, sorry, it will be 3a over root 2. Okay, let me correct this. It will be 3a over root 2. So if I apply this, 3a over root 2. So a is root 2. Let me erase this part. A is root 2, so we can cancel 3. Here is 3a root 2, so it's 3 root 2 times root 2 because a is root 2 over 2. So 2 will be cancelled by root 2 times root 2. 3 times 3 is 9. So the answer is which choice? Choice A. Okay, it was problem 16. Now let's try problem 17. Try problem 17 first on your own. Okay, let's just start. Here it says minimum number, that if you consider consecutive number, they are not prime. Okay, and then it says it is the smallest, find the greatest. When we want to find greatest, the first digit should be what? To be greatest. If 9 is possible, we should place 9, and then we should check, is it possible or not? For example, one case, you say, okay, 9, 8, 7, 6, 5, 4, 3, 2, 1. But the problem is what? 98 is good, 87 is good, 76 not prime, 65 good, 54 good, 53 is bad. Okay, so we say, let's consider 5 here. After 4, 53 is not good, 50. Let's consider something. Let's consider 4 up to 4. Then after that, 43 is bad. 41 also is bad prime, so we can have only 42. Then 1 and 3 are left. 23 is bad, 21. Again, here we have bad. So if you have 4 here, it will be bad. Okay? Now, because 42, it will be bad. So we can say what? Let's check 98765. Instead of 4, we can use what? 50. What is not prime? After 4, it's better to check 53, not good, prime. 52. Then, what digits are left? 1, 3, 4. So 21, 24 we can place. But 24 is better because it's larger. So for 24, what digits are left? 1 and 3. 41 is bad, 43 is bad. So it is bad for 1. 3 and 4 are left. You should place 1, 4, then 3. Again, it is bad. So we've checked 52. Now let's check 51 because it's not prime. What digits are left? 2, 3, 4. We can place 12 or 14. Now when we place 1, 2, 3, 4 are left. 23 prime, 4, 3. Again, it's bad. 1, 4. 42 is good, then 23 is bad. So we've checked all cases that we have these numbers here. So we can understand that 5 is not good to place here. Okay? If we want to change, we try to change from rightmost digits because, for example, if we change this 9, it will be so much smaller. So we saw that here we cannot be 4. We've checked all other cases. Now we say, okay, here we cannot have 5, so let's continue. In next part, we try to change 5. 9, 8, 7, 6. Let's change it with substituted with greatest digit after 5. It's 4. Okay, now again, after 4, if we check greatest one, it's good to place 5. Then what digits are left? 1, 2, 3. Okay, 2, 6, or 3, 9. Okay, greatest one that we can place is what? 52. And then 21, but 13 bad. So if you have 50, we can say 51. 2 and 3 are left, 12. Then let's erase the commas. Okay. So 51, then 12, 13 not possible, 23 will be bad. Okay, so sorry. One thing that's okay, now it's good. 4, 5. Now we've checked after 4. If it is 5, it's bad, not possible because we've checked all cases that we have 5 here. 9, 8, 7, 6, 4. Okay, so try to check all cases of 4. For example, we have 45. After 45, we have 43 not prime, 41 not prime, 42. See, is it possible? And then if it is not possible, we'll understand, okay, 4 is not also possible. We should check another number. Try the rest on your own. Okay, so here it is 4, it is 2. What digits are left? 1, 3, 5. Okay. So 20, what 25 is the best that we should check then if doesn't work 21. So here 5, what digits are left? 3, 1, 53, 51. We should place 51, but 13 is bad. Here 1, and what digits are left? 3 and 5. So we have to place 5 here because 13 is prime, but here is bad. Okay, so we've checked 2 and it is bad. So what digits are left? 45, we've checked 45. 42, 43, 41 are bad. So we understand that we cannot place 4. So the next digit that we should check is what? 9, 8, 7, 6, 3. What digits are left? 1, 2, 4, 5. Okay. The best number after 3 that is good to check is what? 35. Or we can say 34 or 32. Let's see which of them is good. And let's check from the greatest one because we want to find greatest number. 4, 2, 1 are left. So all of them are good. So if you check, for example, place 41, 54, let me check other cases. 54, 52, 51. And we place 54, 2, 1 are left. Oh, so we can place 2 and 1, the greatest one. 54 not prime, 42 not prime, 2, 1 not prime. Okay, so it is our answer. The problem says what? Fifth digit and sixth digit. So 1, 2, 3, 4, 5, fifth digit, sixth digit, 3 and 5. So the answer is choice E. Okay, so here we've answered this. Now let's try next problem. Problem 18. Okay, so try problem 18 first on your own. Okay, for this problem, we write 1 plus 2 sine x, and for the rest, we factor from negative 4 sine squared x. So it will be 1 plus 2 sine x equals 0. So if you factor from 1 plus 2 sine x, it will be 1 minus 4 sine squared x equal to 0. So as idea, how many ideas? We worked on 22. Idea 23. A squared minus b squared is what? If you factorize a minus b times a plus b. Also, we have same thing for a n minus bn, which is a minus b times a n minus 1 plus a n minus 2b up to b to the n minus 1. Okay. Now here, if you use this identity, I can say, okay, it is 1 plus 2 sine x, 1 plus 2 sine x, or we can say 1 minus 2 sine x first, times 1 plus 2 sine x equals 0. Okay, so try to solve this equation. Okay, now we can conclude 1 plus 2x is 0, or here again 1 plus 2x, or 1 minus 2 sine x. 1 plus 2 sine x 0, or 1 minus 2 sine x. So here 2 sine x will be negative 1, and we can conclude sine x equals negative 1 half. Here we can conclude 2 sine x equals 1, so sine x equals 1 half. So for these types of problem, one idea is to draw unit circle for the problems, trigonometric problems. Unit circle. It can be so much helpful. And let me tell you also something, idea 25 in general. If sine alpha equals sine beta, then alpha equals beta plus 2 pi k, or beta pi minus beta plus 2 pi k. It is in general, okay? And idea 26, for example, when cos alpha equals cos beta, we have alpha equals plus minus beta plus 2 pi k, which k is integer in both of them. K is integer. It is general. formula, so much useful. And for 27, if tan alpha equals tan beta, you can conclude alpha equals beta plus 2 pi k, or pi plus beta plus 2 pi k, k integer. For cotangent, you can say same thing, cot A equals cot beta, alpha equals beta plus 2 pi k, or pi plus beta plus 2 pi k, okay? K integer. Now, here, sine x negative 1 over 2, sine x 1 over 2. So, sine x, when it is 1 over 2, we know sine of what equals this? Sine of, because in this problem, we are working with degrees. For example, it says 0 to 360. We can also work with radians. Let's work with degrees, sine 30. Okay, so if we use the formula here, we can say x equals alpha is x, beta is 30. Beta 30 plus 2 pi k, pi is 180, plus 360k, or pi minus beta, 180 minus this, 150 plus 360k. Because our answer should be from 0 to 160, here we will find only two angles, 30 and 150. Next one, if we use same thing, sine x equals negative 1 over 2. So sine negative 30. Why? Because if you draw unit circle, you can easily see that sine is vertical one. Alpha, negative alpha. Sine negative alpha equals negative sine alpha. Sine negative alpha equals negative sine alpha. So we know sine negative 30 equals negative 1 over 2. Okay, so x equals negative 30 plus 360k, or 180 minus this 210 plus 360k. Okay, so because k is integer, it should be between 0 to 360. Okay, here 0 to 360. So it will be what? It will be, we should add 1, 360 is 330, and here 200. And if I want to show you on unit circle that what are the angles that are good, 30 will be something like this, negative 30 will be this one, this one, this one. This part is 30, this one is 150. Sine of them is 1/2, negative 30 or 330, and 210 will be this. These 4 points. So how many solutions are there? 4 solutions. So the answer is what? The answer is C. Also in AMC, we have problems that you should use these formulas. How many homeworks do we have? Homework 13. Homework 14. In AMC, we have problems that can be solved with this idea. If you want to know exact problems are what, I should search. Feel free to send message to my WhatsApp number in the description and comments. Okay, it was problem 18. Now let's try 19. Try problem 19 first on your own. For this problem, we should use some rules in divisibility. Idea 28, idea 29. Divisibility, for example, A divides B. The properties. Okay, here we say 2n plus 3 divides 7n plus 12. We know 2n plus 3 divides itself. This sign means divides. A divides B. 2n plus 3. Now I want to get rid of n. So we have one property that if, let me write some properties, I30, A divides A, we've used this, I31. If A divides B, then A divides BC, and you can prove them by definition. Okay, definition is what is there exists K, that for example B equals AK, which K is integer. By this you can prove this. So, for example here A is 8 times 1. So let me see how many homeworks do we have. Homework 14, homework 15. Try to prove this, homework 15. Here the proof is easy. Say A is 8 times 1. Okay, so 2n plus 3, I want to get rid of 7n, so I multiply this by 2, this by 7. 14n plus 24. If you want to work on all properties, I explain completely, as I said before, feel free to send message to my WhatsApp number in the description and comments. So 2n plus 3 divides 14n plus 21. Now if you subtract 2n plus 3 divides 3. So 2n plus 3 equals plus minus 1 plus minus 3. And why we can subtract? Because of idea 32. If A divides B, A divides C, we can say A divides B minus C. As homework 16, try to prove it. Prove this part. Okay, 2n plus 3 is a divisor. Divide 3 plus minus 1 plus minus 3. And it said what? It says what is the sum of all such integer values? And it is integer, not positive integer. So let's calculate all n's. So 2n plus 3 can be 1. Let me write 1, negative 1, 3, negative 3. So we can subtract 3, so it's negative 2, negative 4, 0, and negative 6. Okay? And then we divide by 2, negative 1, negative 2, 0, negative 3. And if we add all of them, answer. Here we want to find answer of, it says, sum of all integer values of this expression, not n. 7n plus 12, 2n plus 3. Okay, so 7n plus 12, 2n plus 3. Okay, if you calculate the first one, it's negative 7 plus 12 is 5 over 2 times negative 1 plus 3 is 1. And next one, negative 2, negative 14, it's negative 2, negative 4 plus negative 1, 0, 12 over 3, which is 4. And negative 3, negative 21 plus 12, negative 9, negative 6 plus 3, negative 3. So it will be 5, 2, 4, and this one is 3. Okay, so the answer is what? The answer is sum of, let me erase this part. Sum of these values, 5 plus 2, 7 plus 4, 11 plus 3, 14. So the answer is choice E. Okay, in number theory, you should get good at divisibility and moduli. If you want to know the properties, how to apply them, feel free to send message to my WhatsApp number in the description and comments. Homework 16, homework 17. Let me tell you some homeworks. For example, try to solve this. N plus 2 divides n squared plus 3n minus 2. And then 2, okay, and n is what? And n is integer. Find all possible values. Homework 18. Suppose n minus 3 divides 5n cubed plus 4n squared minus 3. Okay, and another one, homework 17. For example, suppose d divides n squared plus n minus 3, d divides 2n plus 1. Here, find all possible values of n in all of them n integer. Here, n and d integer. Here, n is integer. Try to find d is what in this case. Okay, all possible values of d. Okay, 17, 18, sorry, 19. If you want to solve more problems, more homeworks, or want hint for these homeworks, as I said before, feel free to send message to my WhatsApp number in the description. Okay, it was problem 19. Now let's try 20. Okay, so try problem 20 first on your own. Okay, let's start. They start from, it says we have two, Jenny and Vicky start with same speed and in opposite direction along the edge of the field. Okay, so one of them here, one of them here, and they meet each other at M. Okay, now, so because they have same speed, it means that this length equals this length. So P plus R equals, let's define this hypotenuse A, Q plus A. A is what? By using Pythagorean theorem, it is the square root of P plus Q squared plus R squared. Now we want to get rid of this square root, so we subtract Q from both sides. P plus R minus Q equals square root of P plus Q whole squared plus R squared. So let me tell you one idea or identity, let's say. Idea 32, 33. So that A plus B plus C squared is what? It is A squared plus B squared plus C squared plus 2AB plus 2AC plus 2BC. And A plus B squared, this one is obvious. A squared plus B squared, you can write it twice. And multiply, you will reach this. Okay, so try these identities, try to raise to the power of 2, and then try to find Q in terms of P and R. Try first on your own. Okay, let's raise both sides to the power of 2. If we use identity 33, left hand side will be p squared plus r squared plus q squared plus, because negative q squared is q squared, 2pr. 2p times negative q will be negative 2pq minus 2rq equals this part. The square root will be cancelled, so it will be p squared plus q squared plus 2pq plus r squared. P squared, q squared, r squared will be cancelled from both sides. Now 2pq, we take these to other sides, so it will be 2pr. And because we want to find q, so we take all things that contain q to one side, these two things, so 2pr equals 2pq plus 2pq, 4pq plus 2rq. If we divide both sides by 2, we have this. If we factor from q, it will be 2p plus r. If we divide both sides by 2p plus rq and switch left hand side and right hand side will be pr over 2p plus r. Okay, so the answer is what? Is choice C. Okay, so now let's work on next problem. Let's see, problem 21. Okay, try problem 21 first on your own. Okay, for solving this problem, we have one important idea and basic. Here I told you up to idea 33. Idea 34. Idea 34 is what? If you have a circle and we have a line tangent to this one, if we connect O to this one, this line, it will be perpendicular. Okay? Now here, if we connect O to X, it will be perpendicular. Okay, and here OP is what? Is root 3. OX also radius root 3. And this angle is 60. Okay, so if we consider OR as X, because this angle is equilateral triangle 60, we can say, okay, X root 3 over 2 is root 3. Because angle opposite to 60 is root 3 over 2 times hypotenuse. So this one, so X will be 2. Okay, X was this part. So the length of, and when it is 60, this one is 30. And X is 2. So opposite to 30 is half of hypotenuse is 1. Now QX is what? QX is QR minus RX. QR is what? Is RP, because equilateral triangle, and RX is what? Is 1. RP is what? Is 2 plus root 3. So it will be 2 plus root 3 minus 1, which will be 1 plus root 3. So the answer will be choice D. Okay. Let's solve next one, 21, 22. Okay, try problem 22 first on your own. Okay, problem 22 says which diagram could be a sketch of the curve y equals sine of r cosine x. For this problem, again, we should consider unit circle. Let me draw the circle. This one, this one. Okay. Now, when you want to find cosine r cosine x, you can select angles from 0 to pi. Okay, let me tell you. Idea 34. Idea 35. And let me explain for you cosine r cosine x is what. When we say that, for example, alpha equals cosine inverse x or r cosine x, it means what? It means that cosine alpha equals x, but alpha can be from what to what? From 0 to pi. Okay? For example, as idea 36, if we have arc sine x, sine inverse x, or arc sine x, if it is, for example, alpha, then sine alpha equals x, and here alpha is from negative pi over 2 to pi over 2. It is so much important. Okay, now I want to solve this problem with two solutions. The first solution is to replacement, try to check some answers and see which of them work. Okay, solution 1. Let's consider x0 first. So sine, cosine, r cosine 0. And you can say cosine of what angle is 0? From 0 to pi, pi over 2. Okay, so it will be sine of pi over 2. So it will be 1. Sine of pi over 2 is 1 because sine is vertical sine, vertical axis. So for which of them, if x is 0, y is 1, we can reject this one because x 0, y is 0, this one, okay, this one. A and C are left. Now we consider x equals pi, for example. The difference of these two things, if we check x pi or x0, we've considered x pi over 2, and let's consider, we should, because these two things are similar, let's consider something negative, okay? So we can consider, sorry, x negative 1, I mean. If we consider negative 1, if we consider x positive 1, then we cannot reject, it will be 0. But let's check x negative 1, then sine of r cosine, cosine inverse negative 1. Cosine of what angle is negative 1? Pi. So sine pi is what? Is 0. This. So this one is 0, this one is not 0, so we can understand the answer is C. Now let me tell you complete solution or solution number 2. For solution number 2, I say, okay, let's consider this angle is alpha. By the definition, I know cosine alpha is x, okay? And sine alpha is what? Sine alpha is y. I know x squared plus y squared is cosine squared plus sine squared is 1. It is a circle, okay? But here, because we know alpha is from what? By the definition, alpha is from 0 to pi. So we can conclude, because it is from 0 to pi, it will be this part. So sine is from 0 to 1. Means y is from 0 to 1. Y is greater than 0, less than or equal 1. So it is part of the circle that y is non-negative or on top of x-axis. So it will be this semicircle. Okay, it was complete solution. Solution number 2. Okay. If you wanted to learn other ideas or similar ideas and background ideas of other exams like BMO, as I said before, 40, 50 important formulas in each topic, feel free to send message to my WhatsApp number in the description. Okay. Problem 22. Now let's try 23. Okay, try problem 23 first on your own. Okay, let's consider the rectangle first. It says, okay, x, let me draw 60, example 61, 80. Okay. Now, here it says the length of a rectangular piece of paper is 3 times its width. The paper is folded so that one vertex lie on top of the opposite vertex, thus forming a pentagon shape. Okay, so if we move it here, then we can say what? So in this figure, for example, it is A, it is B, it is C, it is D. Now when D should go on top of B. Okay, so you should see the new figure is what? If we, you can, for example, do it on your paper to see what happens. Try first on your own. Okay. Okay, so look, when we want D goes on top of this, for example, let's select something from this part. We fold this one and D goes like this. So we can understand that this is equal to this. And for example, this one is E. Okay. And then it will be what? Here, D is now on this point. So we can conclude A is here. Okay. And the rest will be like what? Okay, and it will be what? It will be something like this. For example, E, like this one. If you consider, let's continue this like this, and let me say this is 90, okay, and something like a bit this one and this. Okay, now try to calculate area. Try to calculate the area, the answer of the problem first on your own. Okay, so in this problem, because it says the length is 3 times the width, so without loss of generality, we can consider it is 1, and this one is 3. This length is x, or we can consider it is a. It is a. So this one, because it is 3, 3 minus a, this one is 1. This one also equals this one. This one is b. This one, let me write. This one is b. This one is b. This one is 1. This one is 3 minus b. So you can use Pythagorean theorem to find a and b, and then you can solve the problem. Try first on your own. Okay, let's calculate a and b. Here in this triangle, we can say 1 squared plus 3 minus a squared equals a squared. So 1 plus 9 minus 6a plus a squared is a squared. You can subtract a squared, 6a equals 10. So a equals 10 over 6, so 5 over 3. So a equals 5 over 3. 3 minus a is 4 over 3. Because 3 minus this one is 1. Now here, look again, this triangle and this triangle are equal because look, 1 and b, sum of these two equal to 3. Sum of these two equal to 3. And here, if we write, we will reach, we can say they are congruent. Okay, so 1, this b will be what? It will be similar to this 4 over 3. This one 4 over 3. So this length is 5 over 3, 3 minus 10. You can also write Pythagorean theorem, you will see it will be exactly this. Now, if you want to calculate area of the pentagon, we can say EF, area of A, you calculate area of A, B, C, E, F, over area of A, B, C, D. Area of A, B, C, D is so much easy, is 1 times 3. Look here, we can also write, for example, 1 as, for example, C, CD as 3C. Okay, then C's will be cancelled because in numerator and denominator we have C squared. And this area is area of ABF, this triangle, plus area of this trapezoid, plus area of BCEF. Area of ABF, this triangle, is this times this over 2, 4 over 3, times 1 over 2. Plus area of BCEF, BCEF is height, area of trapezoid, is 1 times sum of the bases, 4 over 3 plus 5 over 3 over 2 over 1 times 3 is 3. So if you simplify, we can multiply both numerator and denominator by 2. 2 we will cancel here, 6, 4 over 3 plus 1 times 4 over 3 plus 5 over 3, 9 over 3, which is 3. Now if you multiply both numerator and denominator by 3, it will be 18. 4 plus 3 times 3, 9. So it will be 13 over 18. Okay, so the answer will be choice D. Problem 23. Now let's try problem 24. So try problem 24 first on your own. Okay, so for this figure, let me. So for this figure, let's consider, for example, at first, the angles are what? Sum of the angles equals 180 times n minus 2. And when it is regular, each angle, you can divide it by n. So here it will be 180 times 6 minus 2 over 6. So 30, 4 times 30, 120. So each angle is 120. Now, if you consider this one a, this one is 1 minus a because the length of all sides equal to 1 from assumption of the problem here. This one is 1. This one is a. Suppose this length is x. Okay? It is x. Now we want to find x is. Also, this one is x. Now, if we draw perpendicular from here, because it's 120 each angle, this angle is 60, and this angle is 30. So this angle is 60. So try to find this x and this x, then consider equal in terms of a. Then you can find a, then you can find x. Try first on your own using this. Use this hint. Okay, if you consider this one, it is a, it is a right angle triangle, it is opposite to 60, so it is a root 3 over 2. This one also is a root 3 over 2. So x equals a root 3 over 2 plus a root 3 over 2, so x equals a root 3 by the first one. Now try to use this part and find x in terms of a. Try first on your own. Okay, in this problem, in this part, when we have trapezoid, draw altitudes. Okay, draw altitudes. This idea is important. So, if we draw the altitudes, because it is 60, it is 1 minus a. So this angle is 30. So this part is 1 minus a over 2. Similarly, this part is 1 minus a over 2. This one is a. So x equals 1 minus a over 2 times 2 plus 1. Now we can say it is what? It is 1 minus a plus 1, which is 2 minus a. So a root 3 equals 2 minus a. So if you take a here and factor from a times root 3 plus 1 equals 2. So a equals 2 over root 3 plus 1. Now if you multiply by root 3 minus 1 and root 3 minus 1, then the denominator will be 2. The numerator is 2 times root 3 minus 1. And we can cancel 2 from both sides. So a will be root 3 minus 1. And now x is what? X is a root 3 or 2 minus a. So x is 2 minus a root 3 minus 1. 2 minus minus 1 is 3. 3 minus root 3. We found length of the square 3 minus root 3, which is choice B. In regular hexagon, we have lots of other things. As homework, it is A, B, C, D, E, F. Suppose, for example, this side is A. Try to find, let me see, how many homeworks did we have? Here, no homework, no homework, no homework. Homework 19. Homework 20. Try to find area in terms of A, B, C, D, E, F. Homework 21. Try to find AC. Homework 22. Try to find AD. Okay, we have also similar things for octagon. It was problem 24. Okay, let's solve last problem. Problem 25. Now try problem 25 first on your own. Okay, for this problem, we should consider this term and this term together, this term and this term together. So if I consider these two things, so let me write x cubed y squared minus x y to the fourth. If you consider some this term, this term, this term, and this term, we cannot factorize in a good way. You can try. Then minus x squared y squared plus xy cubed. It should be greater than or equal to 0. Now, from these two parts, we can factor xy squared. So it will be x squared minus y squared. And from this part, we can factor plus xy squared. It will be y minus x greater than or equal to 0. Now, here we can factorize this. It will be x minus y times x plus y plus xy squared times y minus x. Now use this hint and try the rest on your own. Okay, now we can factor from x minus xy squared, x minus y times x plus y. Because here it is x minus y, here it is y minus x. We write 1 minus 1 greater than or equal to 0. Okay, now if we consider the terms, we should see which terms are negative, which terms are positive. So y squared is greater than or equal to 0. X minus y here, x minus y less than or equal to 0. X is greater than or equal to 0 from assumption. So greater than or equal to 0, greater than or equal to 0, less than or equal to 0, because the product is greater than or equal to 0, we can conclude x plus y minus 1 is less than or equal to 0. Okay, now you should consider to this condition, first condition and second condition, and see the area will be what. Okay, try the rest on your own. Okay, let's draw. Here it says x less than or equal y. So we know this line is x equals y, and we should consider only first quadrant because x and y are greater than or equal to 0. Now, x is less than or equal y, so here x is y because x is smaller than y. We should go left, so it will be this area from first one. Okay. Now, from first one, we should select this area. From second one, we can conclude y is less than or equal to 1 minus x. So let's draw this line first. Okay. Okay, if I draw this line, it will be something like this. 1 minus x. It is 1, it is 1. Okay. because y equals 1 minus x. If x is 0, y is 1. If y is 0, x is 1. And now, because it says y less than or equal this, so look, in this point, y equals this. When y is less than this, you should go down. So 2 will be below this line, and on this part, so the intersection will be what? Will be this area. Okay, if you check the intersection, this one is what? Y equals 1 minus x. This one, y equals x. So if we calculate this one on, or we can say it is an isosceles right angle trapezoid. If we consider this line, this angle equals this angle, so we can calculate the area of this triangle and divide it by 2. So 1 times 1 over 2, area of this triangle, we divide it by 2. Because in this isosceles triangle, this one is angle bisector, it is also altitude and median, and it split the area of triangle into 2 equal triangles. So 1 over 4. So the answer is choice A. Okay, if you want to learn other ideas that are useful for SMC or BMO1 or BMO2 or AMC, American Mathematics Competition, AME, USAMO, IMO, any math exam, if you want to prepare, feel free to send message to my WhatsApp number in the description, or if you want to learn 40, 50 important ideas and formulas in combinatorics, algebra, number theory, and geometry. Okay, thanks for watching this video. Bye.